Today we're going to look at lesson 10.4, and the title is the inverse of a function. Now let's talk about functions because we have done a lot of work with functions already this year. And if you're not sure about what I'm about to ask, look at the notes that I gave you. Okay, look at the original problems and see if it helps you answer my question. But when a problem is written in function form, what does the problem have in it? Try again. F of x. When a problem is in function form, instead of a y, you're going to see an f of x. Now that leads us to the essential question, how are a function and its inverse related? Okay, so you've got some blanks to fill in on your notes, so go ahead. It's an inverse relation. Inverse relations switch the input and the output values of the original relation. So you are basically switching your input values and your output values. Now, what variable represents our input values? Okay, and you can put that into your notes if you'd like. And what variable represents your output? Y. All right? So we've done a lot of this before, but this is inverses. We're going to switch the x coordinates and the y coordinates. And you can see that right here. If the relation is the ordered pair AB, its inverse is going to be BA. So we like example 1 because it says find the inverse of each relation. And it's going to be real simple. We're going to take these ordered pairs and we're going to switch the coordinates. So Jamie, if the first ordered pair in letter A is negative 4, 7, what is the inverse of that going to be? 7, negative 4. Awesome. Isaac, if the second ordered pair is negative 2, 4, what's the inverse going to be? 4, negative 2. Landon, if the ordered pair is 0, 1, what's the inverse going to be? 1, 0. Jace, if the ordered pair is 2, negative 2, what's the inverse going to be? And lastly, Amy, if the ordered pair is 4, negative 5, what's the inverse going to be? Negative 5, 4. All right? So when the function is given to us as ordered pairs, finding the inverse is a piece of cake, right? Now, letter B, I gave you a table, an input and an output table. I still have given you ordered pairs, right? Because what is my input? My x values, and my output? Y, all right? So go ahead and draw you. If they give you a problem as a table, your answer, the inverse, also needs to be on a table, okay? So if the first ordered pair on this table is negative 2, 4, how am I going to write the inverse, Julia? So the 4 is going in the input row, the negative 2 is going in the output row. All right, Ella, if I give you negative 1 and 1 as the ordered pair, what's the inverse going to be?
Positive 1, negative 1.
Okay, 1 is going in the input row and negative 1 is going in the output row. What about 0, 0? Is anything going to change if I switch 0, 0? No, it's just still going to be 0, 0. And what about 1, 1? Nope, just 1, 1. All right, Anna, 2, 4. If the ordered pair is 2, 4, what's the inverse going to be? 4, 2. Now, that takes us into example 2. All right, we're going to build on this just a little bit, and we're going to talk about solving y equals f of x for x. All right, so they're giving us a piece of information in these directions that we already know, we've known for a really long time because you guys told me earlier. Okay, y and f of x are the same, and we already know that. But what they're asking us to do is to take this equation and solve it for x, and that actually takes us back to chapter 1 when we solved literal equations. If you remember chapter 1 and literal equations, you had an equation with more than one variable. You had an x and a y. And when they ask you to solve for one or the other, it just means we have to get that variable on a side by itself. So let's start with that. Looking at letter A, let's go ahead and change the f of x to a what? To a y. Okay? And it equals, we bring down the x minus 6. Now, they want us to solve for which variable? X. So I'm going to go ahead and circle it. And this is just basic solving equations. How am I going to get x by itself? I'm going to add 6 to both sides. Good. Can I combine a y and a 6? No, they're not like terms. So I'm just going to bring down y plus 6 equals x. Now, you know me, I like the variable that I have isolated on the left side. So I'm just going to rewrite this and put the x on the left and the y plus 6 on the right. And I'm going to box this in because that's the first thing they've asked me to do. They've asked me to solve for x. Then it says find the input when the output is 4. So they have given me a value of 4. The question is, which variable am I supposed to be plugging that 4 in for? Y. Very good. So I take the equation that I just wrote, and in place of y, I'm going to plug in a 4, and that helps me to solve for x. What is 4 plus 6? 10. So the other part of my answer is x equals 10. Let's do that again. F of x, we're going to change to a what? To a y. It's going to equal the 4x squared. All right, what are we solving for? We're going to solve for x, and we'll notice this time that there's a squared on our x, but that's okay. Let's get that by itself first. How do we isolate x squared? We're going to divide both sides by 4. Can we do anything to simplify y divided by 4? No. So we're just going to, and I'm going to go ahead and switch and put the x squared equals y over 4. Okay? Now, we're not panicking because we know how to get rid of a square. How do we get rid of a square? We square root. So we are going to take the square root of both sides. Be careful. If we put a radical into the problem, what else do we put into the problem? Plus or minus. So that has not changed. What is the square root of x squared? X, and it equals plus or minus. Now what did we learn? And we can even do it just over to the side. What did we learn to do when there's a fraction under the radical? Separate it. So we have the square root of y divided by the square root of 4. Can we simplify the square root of y? No. So we leave it, but what is the square root of 4? 2. So there is our equation when we solve for x. Now, we still have a 4, and where are we supposed to plug it? In place of y. So x equals plus or minus the square root of 4 divided by 2. So what is the square root of 4? 2. And what is 2 divided by 2? 1. So x equals plus or minus 1. Now, what happens when they give us a function that is not an ordered pair, but instead they give us a function that is an equation? When they give us a function and they give it to us as an equation, how do we find the inverse? This is where it gets a little bit more involved and a little bit tougher. So here are your steps, and you're going to notice I changed one of them on your notes. All right? So grab your highlighter, highlight the steps, and let's talk about them. Step number 1, we're supposed to change the f of x to a y. Well, we just did that in the last problem, so that should be easy, okay? Here's the key right here. We're supposed to switch x and y. So we are literally taking the variable of x and the variable of y, and we're going to switch them. Then, literal equation, we're going to solve that problem for the y. And lastly, we're going to change the y to a g of x, okay? We can't change it back to f of x because that's our original function, and we're trying to write the inverse, all right? So we're going to change y to g of x, all right? That's just going to be our general thing that we're going to change it to. All right, so let's take these steps and let's look at example 3. They want us to find the inverse of the function. So if you look at letter A, what's the first thing we're supposed to do? Change f of x to y. All right, we've been doing that. No big deal. Step number 2, switch x and y. Now watch what I do. The y becomes an x. The equals and the minus sign come down. The x becomes a y, and the plus 5 comes down. I want you to pay attention to the fact that no sign moved, no number moved. The only thing that switched was the x and the y. And now we're supposed to solve for what? Y, which is right here. So again, basic solving of equations. How are we going to get y by itself? We're subtracting 5. Can we do anything to combine the x and the minus 5? No, so we just bring down x minus 5 and it equals negative y. Is the y by itself yet? No, because there's what in front of that y? A negative 1. And so how do we move that negative 1 to the other side? Divide both sides by negative 1. Now again, this simplifies to a 1, and I'm going to go ahead and bring that y down on the left. A binomial divided by negative 1. Can we do it? Yes, we can. All right. What is that show that they say, can we? Is that Bob the Builder or something? Okay, sorry. Totally went off track there. So, can we divide a binomial by a negative 1? Yes. Yeah, but be very careful. What does it give me? Negative x. That's what I heard. Negative x. Good. Negative x, because x divided by negative 1 is negative x. Negative 5 divided by negative 1 is positive 5. All right, good. And we're supposed to change the y to a what? To a g of x. Now, do you notice anything about our original function and our inverse? Okay, that's okay. Is it going to happen every time? I don't know. Let's see what happens when we do letter B. But we're not going to panic yet that the function and the inverse match each other. All right, let's do letter B. We're supposed to change what first? F of x to y, so y equals 1/4 x minus 1. Then we're supposed to switch. So again, the y becomes an x. We bring down the equals 1/4. The x becomes a y, and we bring down the minus 1. All right, what is our next step? We're solving for y. So what are we going to move first? The 1. Jace, how are we going to move the 1 to the other side? We're going to add 1 to the other side. And Jace, can we do anything to combine x and 1? Good. I want to make sure nobody brings down a 1x. That is x plus 1, and it equals 1/4 y. Now, here we are again. We got to go back to chapter 1 because we need to move a fraction to the other side of the problem. And if we don't remember how, we're going to be in trouble because we can't put a binomial into the calculator. So does anyone remember, by show of hands, how do we move the 1/4 to the other side of the problem? Landon. You do multiply. What do you multiply by? Not the inverse, the reciprocal. And I think that's what you meant, okay? What is the reciprocal, everyone, of 1/4? 4 over 1, or just 4. So we're multiplying both sides by 4. So y equals. Now, be very careful again. We have a 4 times a what? What do we call this right here? A binomial. So what is 4 times x plus 1? Very good. Because we used what property? Very good. And you're like, if you're thinking, I did not know that, draw yourself some arrows. You got to do 4 times x and 4 times 1. All right, great job. So the y then changes to a g of x, and it equals 4x plus 4. Now, does this inverse match the original function? No, okay? So it's not always going to be, the inverse is not always going to be the original, all right? But it's okay if it is. We're going to take all this information and we're going to move into example 4, which is a graphing problem. All right, you can notice that there are like 3 or 4 different things they want us to do. So let's look. They want us to find the inverse of the function, which we've just done twice, so that shouldn't be a problem. Then they want us to graph the function and the inverse. So we're going to be graphing 2 things on our coordinate plane. And then they want us to determine if the inverse is a function. Is that graph, is that inverse a function? And we're going to use something called a horizontal line test. We've done a vertical line test before, but today we're going to do a horizontal line test. So let's start with what we already are comfortable with. Let's find the inverse. So the first thing we're supposed to do is what? Change everyone. What are we supposed to do first? Good. We're going to change f of x to a y, and we have negative x squared. All right. What are we supposed to do next? We're going to switch. So the y is going to become an x. We bring down the minus. The x becomes a y, and then we bring down the squared. So once again, make sure you're very careful. No power moves, no sign moves. We literally have just switched the x and the y. All right? Now, we're supposed to solve for what? We're supposed to solve for y, so what are we going to move first? That negative 1 that's in front of the y. So we divide both sides by negative 1. And guys, what's x divided by negative 1? Negative x. And it equals y squared. Now, once again, we are not scared of y's. And we're not scared of squares, because how do we get rid of a square? We square root. So we are going to square root both sides. But what also has to go into the problem? Plus or minus. And make sure you put it on the right side. All right? Put it on the right side. So what is the square root of y squared? Y. I'm going to go ahead and put it on the left. And then, of course, we have plus or minus the square root of negative x. Now, please do not stop and say no solution. Because we're so used to when there's a negative underneath a square root saying there's no solution. But that's a negative variable. What happens if I plug a negative number in for x? I have a double negative, and the number under the radical becomes a positive, okay? So we're going to keep going. This is not going to make us stop. But we do have to be very careful, all right? This is probably the most difficult thing I'm going to tell you today, all right? We cannot leave the plus and the minus in the problem, okay? So this is where, if you go back up here, the domain comes into play, all right? You see the domain that they gave us in the original problem? It says x is less than or equal to 0. So here's what I do. I take my highlighter and I'd highlight that domain right now. Now, if my domain are x values that are less than or equal to 0, what kind of numbers are my domain? Negative. Which means my y values also have to be negative. So that means, which sign am I going to keep? The negative sign. So that means when I write this final answer, g of x equals, it's the negative square root of negative x. So I'm going to go over that again, but I would highlight the domain, make it stick out, and then I'd actually highlight the plus or minus and then show, and I'd highlight the final sign because I'm not going to keep both. Okay, the domain has given me a restriction of x is less than or equal to 0. So if my x values are restricted to negative numbers, my y values also have to be restricted to negative numbers. Now, keep in mind, I'm supposed to graph the function and its inverse. So my function is up here. My function is the original problem. So go ahead and open up Desmos. And remember, I can't use f of x in Desmos. What do I have to use? Y. So y equals negative x squared. And then if you remember back a lot when we did piecewise functions, I don't know if you can go back that far, all right? But we have to put that domain in Desmos so that only the part of the graph we need shows up. So here's what you got to do. You got to hit that ABC button. You see that ABC button? And then you see the button that is the brace. Okay, I call it the brace, not the bracket. You want the brace button. Hit the brace. Then you put in that x is less than or equal to 0, and then you close the brace. And that should just give you the part of the graph that you need. Now, once you have that part of the graph in, now you also have to graph the inverse. All right, so you're going to do, again, g of x has to be a y, and then it equals the opposite of, or negative square root of negative x. Now, as you're doing this, I want you to think back to 10.1, all right? This is a radical. This is a square root problem. And you learned in 10.1 that the shape of a square root graph is that like banana shape. Is that what you're seeing on Desmos? Yes, okay? So we are going to graph both of these graphs. So make sure you're giving me the right ordered pairs. Let's start with the parabola. Okay, the original problem was a parabola. Of course, we only have half of it on our paper. So give me some points from the parabola, the original function. Jordan.
0, 0.
I got 0, 0. That's a good one. All right, give me another point. Harley?
-1,
-1, -1. Good. Keep it simple. Keep them close. Give me one more point on that parabola. Amy? -2, -4. Awesome. So we got -2, -4. And then, of course, we can draw that half of the parabola and we put an arrow on the end. Now, let's talk about the inverse, all right? That banana-shaped graph. Give me some points on that one. If you've got some of the same points, make your life easy and use them again. Give me a point.
0, 0.
All right, we got 0, 0 again. What else we got? Colby.
-1, -1.
We got -1, -1 again, so that one's already there. Can somebody give me another one? Harley? -4, -2. Good. Okay. Now be careful. I know this is hard. These are harder to draw because of the way that they are shaped. We're gonna do our best, and remember, it just kind of goes off, and we draw an arrow. Only on one end, though. All right. We only have an arrow on one end, and don't forget to label this third point, the -4, -2. Now the final question is, determine if the inverse is a function. So you've got to make sure that you're looking at the right graph. Which graph on your paper is the inverse function? Okay? The one that looks like a what? The banana shaped, right? Not the half of the parabola. So you're going to perform the horizontal line test on the banana shaped graph. And I would use Desmos. Here's why. We don't want to trust our crude drawing, okay? Our drawings are never as accurate as Desmos. So when you go to do the horizontal line test, look at the graph on Desmos, okay? A horizontal line. You're basically taking a horizontal line, and anywhere you would draw it through that graph, how many times does it hit? That's what you're looking for. How many times does that horizontal line hit that function? Tell me. So there's a point where you draw a horizontal line and it goes through that function. No. Okay. So look, if the inverse is a function, if a horizontal line only touches it one time. So is this inverse a function? You just told me that the horizontal line, the imaginary horizontal lines you're drawing only hit the graph once, right? So is it a function? Yes, according to the horizontal line test, it's a function. And I would just put that right underneath the equation. If it were not a function, we would write not a function right underneath the inverse. All right? That is lesson 10.4.